Hello students, my name is Arundam Pan and I am in this profession, better to say teaching physics for at least 20 years. I have started this YouTube channel to help students all over the world so that they can learn physics without any cost. They can easily learn physics, just they need to have YouTube channel. They can use mobile, they can use computers, they can use anything, just they need to access some internet and YouTube channel. Okay guys, let's start. Today we are going to start dimensional analysis. Normally this chapter is included in class 11 syllabus. So the question what comes in our mind at first is, what is dimension? What is the dimension? The answer is dimension of a physical quantity is defined. So dimension is always of a physical quantity. So dimension is nothing but it is an adjective of physical quantity. Dimension of physical quantity is defined as the powers to which the units of fundamental quantities should be raised to obtain the unit of the given physical quantity. So this is the definition, but the definition is not very clear if you just don't have the example. So at first we would learn an example through which we would learn the definition. For example, we are going to find out the dimension of velocity. So dimension of velocity is written as like this. Velocity within third bracket, it means the dimension of velocity. So whenever we write any physical quantity within third bracket or square bracket, then it indicates that the dimension of that particular physical quantity within the bracket. So velocity, we know that displacement by time. Displacement by time. Displacement means length. So Why we are just substituting displacement by length? Because here we have written units of fundamental quantities, so we have to substitute every physical quantity by the fundamental quantities. So here we write displacement as length L, time, it is also fundamental quantity, L by T. So ultimately it becomes L T to the power minus 1. Now here is no m, mass is also fundamental quantity, so we write this as m to the power 0 L T to the power minus 1. So this is the ultimate formula for dimension of velocity. So whenever we write the unit of velocity, we should write length, that is meter, its power raised to 1, time, its unit is second, and its power is raised by minus 1. So ultimately the unit of velocity is meter per second. This is very simple. Now we are going to find out the dimension of acceleration. So acceleration is equal to the change in velocity, that is unit of velocity divided by time. Velocity, again we know that L T to the power minus 1, as we have just derived it earlier, L T to the power minus 1 by T. So ultimately it becomes L T to the power minus 2. So m to the power 0 L T to the power minus 2. If any one of m, L and T is absent, we write its power as 0. Okay, so here m is absent, that is why we have written m to the power 0. Next, another physical quantity, say momentum. So momentum equals to mass into velocity. So it is mass means m, velocity L T to the power minus 1. So ultimately it becomes m L T to the power minus 1. So using the basic formula, we can find out the dimension of any physical quantity, right? So you have learned what is dimension and how to find out the dimension of a physical quantity, right? I have just given some examples, but there are several examples. You need to study all those dimensions, all the dimensions of physical quantities from your book. So study all the dimensions from your book. Don't forget, or better to say, don't miss any dimension, because it is very important throughout your life. Next, we are going to study the application of dimensional analysis. Why are we going to study dimension, or better to say, what is the utility of dimensional analysis? There are several applications. Application 1 is to find the unit of a physical quantity. Number 1, to find the unit of a physical quantity in a given system of unit, in a given system of units. For example, we need to know the unit of force in SI system. We know that the dimension of force is m L square T to the power m L T to the power minus 2, m L T to the power minus 2. So its unit should be, just substitute m, L and T by the units of the given system. Here it is the SI system, so we substitute the unit of force equals to m means kg, L means meter and T means second. Kg meter is to the power minus 2. So it is the unit of force, and we say it a Newton, that is Newton. So applying this technique, you can find any unit of a physical quantity of a particular system. Suppose you can easily find out the unit of force in CBSE system. You can find the unit of force in FPS system, right? So this is application 1. There are several other applications. I am just coming to these other applications. Here the application 2. What is application 2? To find the dimension of physical constant or coefficient. For example, we can easily find out the dimension of gravitational constant. What is gravitational constant? From Newton's law of gravitation, we know that if, that is, gravitational force is directly proportional to the product of the masses m1 and m2, inversely proportional to the square of the distance between them. So ultimately it becomes F directly proportional to m1 m2 by r square, implies F equals to some constant, that is constant of proportionality. We write it as capital G, which is known as universal gravitational constant. So G m1 m2 by r square. Now G is not dimensionless. From dimensional analysis, we can easily find out the dimension of this G, that is gravitational constant. So write all the dimensions of these physical quantities except G. So we know, we write dimension of F, that is m L T to the power minus 2. G is unknown, equals to G unknown, into m1 m2, that is product of masses m square, it becomes r. R means the distance, so it is equal to length L, it is L square. So after cross multiplication we get dimension of G equals to m L t to the power minus 2 into L square by m square. Thus this is equal to m to the power minus 1 L cube t to the power minus 2. Very simple. Our application 3 is application number 3, to establish a relation between different units of a physical quantity. For example, we can easily find out the relation between the CBSE unit and SI unit of force, or we can easily find out the relation between CBSE unit of energy and SI unit of energy, applying dimensional analysis. So at first we are going to do the relation between the CGS and SI unit of force. Yes, I'm just erasing this and writing it from the beginning. Find out the relation. It is an example of the application 3. Let one at first we write the CGS unit of force is dyne. SI unit of force is Newton. Let 1 Newton equals to x dyne. Suppose 1 Newton equal to x dyne. Next we write the dimension of each in two cases. Newton, it is in SI system, dyne is in CGS system. We have learned previously that we can write the units in the form of dimensions. For example, Newton can be written as kg meter second to the power minus 2. Similarly, dyne can be written as centimeter gram centimeter second to the power minus 2. Gram centimeter second to the power minus 2. So, in general, we can write these as 1 M1 L1 T1 to the power minus 2 equals to x M2 L2 T2 to the power minus 2, where M1 L1 and T1 are units in series. Just I am writing it in brief. Actually, M1 is the CGS unit of mass, L1 is the CGS unit of length, and T1 is the CGS unit of time. Similarly, here M2, L2 and T2 are units in SI. So ultimately X equals to M1 L1 T1 to the power minus 2 divided by M2 L2 T2 to the power minus 2. So M1 by M2, L1 by L2, T1 by T2 whole to the power minus 2. You know M1 is in CGS system. Sorry, it should have been SI, because we have written M1 below Newton, so it is in SI and it would be in CGS. So M1 is the unit of mass in SI system, so it should have been 1 kg by M2 is 1 gram. Similarly, this is 1 meter and this is 1 centimeter. This is 1 second by 1 second to the power minus 2. So 1 kg means 10 cube gram divided by 1 gram. It is 10 square centimeter. 1 meter means 10 square centimeter, and this is 1 centimeter and this is 1. So ultimately it becomes 10 square into 10 cube into 10 square equals to 10 to the power 5. So value of x is equal to 10 to the power 5. Therefore, from this equation we can write 1 Newton equals to 10 to the power 5. Right. So easily we can find out any relation like this. If any unknown relation comes in your exam, you can easily find out by this method. You can do it in your home. Find out the relation between SI and CGS units of energy by the dimensional analysis. Just apply the method I have shown earlier. If you can find it, no problem. Our fourth application, application 4, to check the dimensional correctness of a given physical relation. What does this mean? Actually, it means that any physical relation means relation between physical quantities, can be checked as correct or false by this method. But not only correct but dimensional correct means you cannot check whether the given equation is fully correct or not, but dimensionally it is correct or not, you can check it. It means that, for example, I am writing A equals to B plus C. A is a physical quantity, B is a physical quantity, C is a physical quantity. Suppose this is a true relation. This is a true relation, we have found it. This is a true relation by this method. Now I am writing A equals to B plus 2C, and I am given this particular relation U to check whether this relation is dimensionally correct or not. you have actually you just do the same method as I'm just showing you, going to show you, and you would say that this is also correct. So here is the difference. A equals to b plus c is correct by this method. A equals to b plus 2c is also correct by this method, because here the dimension is the same. There is no change in dimension. Actually, when you just add or actually multiply some constant in the dimensional formula or equation, then nothing changes dimensionally, but actually it changes. So you cannot check whether the given equation is fully correct or not. Actually this equation is fully correct, but this is also correct dimensionally, not fully correct. So you cannot check whether a given physical relation is fully correct or not. Only you can check whether the equation is dimensionally correct. So if I just give you this equation, A equals to B by C, then you would say that no, this is not correct, because A not equal to B by C. It would be very clear if I just use a very common relation. Suppose to check an example, to check whether V equals to U plus AT is dimensionally correct or not. To check this, we must write each and every term of the equation and then find its dimension. First we write V and then find its dimension. It is Lt to the power minus 1, because it is final velocity, that is dimension of velocity. U means initial velocity, so it is also dimension of velocity. Now AT. What is AT? A means acceleration and T means time. So it is L T to the power minus 2 into T. So it is equal to L T to the power minus 1. So we see that all the terms of the given equation has the same dimension. All the terms of the given equation have the same dimension, that is Lt to the power minus 1. So this equation is dimensionally correct. Very simple. So nothing, actually you can easily find out whether the equation is dimensionally correct or not by simply writing the dimension of each and every term and then check whether the dimensions of each and every term is the same or not. If they are same, then the equation is correct, dimensionally correct. If they are not same, the equation is not dimensionally correct. In your home, you can do, actually you can check the following equation. Number 2, S equal to ut plus half at square. Check v square equals to u square plus 2as. If t equals to m v2 minus m v1. F into t equals to m v2 minus m v1. So you can just check all these equations whether these are dimensionally correct or not. Here is application 5. Dimensional analysis can be used as a research tool. It can be used as a research tool to derive new relation, to derive new relation between or among different physical quantities. What is this? Actually, this is a research tool. By this tool, you can easily get the relation between different physical quantities. Suppose, what is the relation between force and momentum? There is some relation, and we know that the force is directly proportional to the rate of change of momentum. Similarly, we can easily find out any relation. For example, suppose the question is time period T, time period tau is dependent on actually write time period of a simple pendulum. Time period of a simple pendulum depends on the length L of the pendulum and acceleration due to gravity. At that place. What is the relation among tau, L and G? This is the question, or the question may come in the following format, right? Or derive the expression for time period. Give the expression for time period. The question may come in this format. Or simply, what is the relation among tau, L and G? We can easily solve this in the following method. Tau depends on L and G. We know that there are two types of dependency, that is directly dependent or inversely dependent. That means even inversely dependent can be written as directly dependent or directly proportional. When the power becomes negative, then it becomes inversely proportional. So we can write anything as directly proportional. If the power comes out to be negative, then it is inversely proportional. Let tau proportional to L to the power A, G to the power B, where A and B are dimensionless constant. A and B are dimensionless constant. Implies tau equals to some constant k, L to the power a, g to the power b, where k is constant of proportionality and is dimensionless. Now here is a flaw, or better to say limit of dimension analysis. If the constant is constant has dimension, then we cannot find out the relation by this method. So here is a limit. We cannot find a relation in which dimensional constant is there. Okay. Now, to write the dimension of each and every quantities. Tau. Tau means time, so it is m to the power 0, l to the power 0 t equals to k is dimensionless, so no problem. L means m to the power 0, capital L, t to the power 0 to the power a into g means the acceleration due to gravity, that is the acceleration. So it is m to the power 0, L, t to the power minus 2 to the power b implies m to the power 0, L to the power 0, t equals to, after multiplication it becomes m to the power 0, L to the power a plus b, t to the power minus 2b. Now equating the powers on both sides. Equating the powers on both sides, so we have written that tau, there are two types of proportionality, directly proportional, inversely proportional. Even inversely proportional can be written as directly proportional. If the power comes out to be negative, then it is inversely proportional. So we write tau directly proportional to L to the power a and g to the power b. If any one of a and g is a or b is negative, then that is inversely proportional. So tau equals to k, L to the power a, g to the power b, where k is dimensionless constant of proportionality. We write the dimension of each physical quantity. So it is m to the power 0, L to the power 0 t equals to k is dimensionless, L means length, m to the power 0, L to the power 0, g means acceleration due to gravity, m to the power 0, L to the power minus 2, and we write the powers on both L and g, that is m to the 0, L to the 0 power a, m to the 0, L to the 0, L to the power minus 2 power b. After multiplication we get m to the 0, L to the power a plus b to the power minus 2b. So here we calculate or equate the powers on both sides. We equate the power of L. L is a plus b equal to 0. Power of t is minus 2b, on the other side is 1. So b equals to minus half. Put minus half here. A equals to minus b, minus of means plus half. So very simple. So a becomes positive and b becomes negative. So from this equation we can write tau equals to k, L to the power half, g to the power minus half. So this is equal to k root over L by g. Actually the value of k can be determined experimentally, and you know that you have studied in your earlier class that this is very famous equation, tau equals to 2 pi root over L by g. 2 pi comes experimentally, but you cannot find out the constant, dimensionless constant by this method. Only you can find out the relation, but you cannot find out the value of dimension constant by this method. It can be found experimentally. Okay, so these is mainly the dimensional analysis. If you like this video, then subscribe my channel. I am coming to you with more videos so that you can excel in physics in your life. You can carry good marks, and I am coming also with some numerical examples so that you can score good marks in your competitive exams like NEET, joint entrance mains, joint entrance advanced, etc. Okay, thank you.